This is geometry, section 14.5, homework, and boy, do I have some good news for you. My app has updated, and now I have a laser. Isn't that cool? Look at the laser. You can assume I'm going to be using this laser a lot. Find the area. Give answers. Give exact answers unless told otherwise. Well, to find the area of a circle, it's pi times r squared. So it's pi times 4 squared. So it's 16 pi. The units are centimeters. So the area would be square centimeters. Number 2, the 16 is the diameter. We are interested in the radius, which is half the diameter. The area of a circle is pi times r squared. So it's pi times 8 squared, which is 64 pi. The unis are centimeters. Number 3 is also giving us the diameter. We want to know the radius to use this formula, which is half of the diameter. So the area of a circle is pi times r squared. That's pi times 16 squared, which is 256 pi square centimeters. Number 4, they're giving us the radius is 10. So the area of a circle is pi r squared. That's pi times 10 squared. That's 100 pi square centimeters. Well, we are just flying through this. Number 5, determine the area of the sector. So to find the area of a sector, we take the central angle divided by 360 degrees times the area of the entire circle. In other words, this is the portion of the circle, and this is the complete circle over here. I should use my laser. In this problem, our central angle is 30 degrees. That's times pi times 4 squared. 30 degrees divided by 360 degrees, well, that reduces quite a bit. Simply, we can say we can divide by 10 degrees on top and bottom and get 3 over 36. And then we can reduce that to 1/12, and then that's going to be times 16 pi. And then we can do some more cross-canceling here. 4 goes into 12 3 times and goes into 6 4 times. So that's 4/3 of pi. The unis here are square centimeters. Number 6, got Pac-Man eating the 3 centimeters. Excuse me for a moment. A little bit of a cough. Define the area of a sector. It's the central angle divided by 360 degrees times pi r squared. Our central angle is 270. You might recognize that as being 3/4 of the circle. And then 3 squared is 9. And you can't do any cross-canceling here because 4 and 9, its only common factor is 1. So that's going to make this 27 pi over 4 square centimeters. Easy, not easy, but quick reminder, multiplying a fraction, laser, times the whole number, you multiply the top times the whole number, and the bottom stays the same, or it's times 1 if you want to make that a fraction. 7 looks like a piece of watermelon. We just don't have any seeds. It's seedless watermelon. To find the area of the sector, we take the central angle divided by 360 degrees times pi r squared. That's 83 over 360. Pretty sure 83 is prime, so it wouldn't have any common factors with 360. Radius is 8. So that would be 64 times pi. Let's see. Oh, the directions say around the two decimal places. I was thinking this is going to be tough to simplify this. So we multiply 83 times 64 times pi, then divide it by 360. And we're going to get about 46.36 square centimeters. Number 9, area of a sector is the central angle divided by 360 times pi r squared. Central angle is 120. You might recognize that as being 1/3 of the triangle. Radius is 9. A third of 81 is 27, I believe. And then if you do 27, the directions, like I like this answer, 27 pi square centimeters, but the directions say around the two decimal places, so we should do that. Throw this in my calculator. 27 times pi, that's 84.82 square centimeters. Number 9. Determine the area of the following figures. Assume lines that appear to be perpendicular and parallel are in fact parallel and perpendicular. Well, what I would do first is I would separate this here, making this a rectangle, and a semicircle. The area of this figure, I think you'll find, is the area of the rectangle plus the area of the semicircle. The area of a rectangle is base times height. The area of a semicircle is half pi r squared. This rectangle has a base of 12 and a height of 3. Keep in mind, the distance from here to here is going to be half of this 12. That's going to be 6. So the radius of this is 6. So that's half pi times 3 squared. It's going to be 36 plus 9 halves pi. I'm sorry, I messed up. This is 6. I wrote a 3. I cut 12 in half twice. Noob. That's going to be half times pi times 36. So we're going to have 36. Half of 36 is 18. So this is the area, and the units we're using is square centimeters. That's the area of this figure. Cool. Number 10. Number 10, I'm going to break apart into 3 different figures. We got this semicircle. We've got rectangle 1, and we got rectangle 2. So the area of this figure is going to be the area of the semicircle plus the area of rectangle 1 plus the area of rectangle 2. The semicircle is half pi r squared. This rectangle is base 1 times height 1. And the area of rectangle 2 is the second base times the second height. Let's see. Let's go back to my picture. This is 5. This also has 1 dash, so it's 5. This has 1 dash, so it's 5. So if this is 5 and this is 1, that's going to make this 1 plus 5, which is 6, which makes the radius for this 3. So the area of a circle is going to be 1/2 pi times 3 squared, which is going to be 9/2 pi. For this rectangle here, we have dimensions of 5 and 6, which is 30. And then for this second rectangle, it's 5 by 1, which is 6. No, it isn't. 5 times 1 is not 6, it's 5, which makes the area 9/2 pi plus 35, and the unis are square centimeters. Number 11, I'll check this out. If I take this semicircle and put it with this semicircle, I'm going to get an entire circle. And then this in here, this green part, is going to be a rectangle, which is a parallelogram. So the area of this figure is going to be the area of a circle plus the area of a rectangle. Area of a circle is pi r squared. If this dimension here is 10, means the radius has to be half of that. So that's pi times 5 squared. That's 25 pi. Rectangles, base times height. Base and the height are 30 and 10. Makes that 300. So the entire area of this figure is going to be 25 pi plus 300 square centimeters. Number 12. Let's see. This one's tough. This one is tough. Let's see, let's break this into parts and do this a little different than the other ones because this one is pretty rough. So this rectangle, I think that you'll find, is the same dimensions as this rectangle. Rectangle 1, rectangle 2, they got the same dimensions. So the area of those fellows right there is going to be the area of rectangle 1 plus the area of rectangle 2. Right now I'm avoiding this whole bottom part because it's a little frightening. So that's going to be a base times height plus a base times height. They're the same, so I'm not going to use subscript variables. So it's 4 times 15 for each of them. So that's going to be 60 and 60. So that's 120 square centimeters. It's for the green part. Well, now let's see if we can worry about this part. Now we don't have a formula to find this red part directly, but we do have a formula to figure out a semicircle. So we could find all of this area, and then we could subtract the part that we don't want, which is this other semicircle. That's going to be our plan for this. The area of this thing here is going to be the area of the big semicircle minus the area of the small semicircle. Let me get rid of all this jazz. So in each case, we're going to take pi times r squared, that's one of the radiuses, minus pi times the second radius squared. Well, what is this big radius? Well, if we look at the distance from here to here is 4, because it shows that up here. The distance from here to here is also 4. So that means this is being cut in half. So this is a 2 and a 4. So this radius is 6. So that's pi times 6 squared. That's 36 pi. The second smaller circle, semicircle, it has a radius of 2. So that's pi times 2 squared. That's 4 pi. That's 32 pi. And this is square centimeters. this first, do this second. The area of the figure is the area of those rectangles plus the area of that weird U-shaped thing. That's 120 square centimeters plus 32 pi square centimeters. Pretty tough problem. Number 13. We have here a rectangle and a semicircle and a triangle. Break this apart. That's going to make this radius 2. This rectangle, so this is a semicircle, this is a rectangle, and this is a triangle. To find the area of the figure, we're going to take the area of the semicircle plus the area of the rectangle plus the area of the triangle. Semicircle is half pi r squared. A rectangle is base times the height, and the triangle is base, is 1/2 base times the height. The reason I used subscript variables, this base is likely different from this base. This height is likely different from this height. And it turns out that's not true in either case, but they could have been. Semicircle, the radius we've established is 2. In the rectangle, the base is 3 and the height's 4. In the triangle, the base is 3 and the height's 4. I am running out of space. So 2 squared is 4, 3 times 4 is 12, half of 3 times 4 is 6, half of 4 is 2, 12 plus 6 is 18. So we're going to get 2 pi plus 18, and the units we are using here is centimeters, so it's square centimeters. Last one. We have a sector of a circle, and then we also have a triangle. Keep in mind that the radius never changes, so this is also 4. The area of this figure is going to be the area of the sector plus the area of the triangle. The area of a sector is theta divided by 360 times pi r squared. The area of a triangle is 1/2 the base times the height. If this is 90 degrees, that means this here is 270. 270 over 360 is 3/4. Radius is 4. So that's 3/4 pi times 16. 4 goes into 16 4 times. 4 times 3 is 12. So this is 12 pi. And then for this triangle, the base is 4. The height is 4. That's half of 16. So that is an 8. The units for these are centimeters, so the area is square centimeters. All right, that completes the assignment. Have a wonderful day.